Boolean logic functions. Now, what does the Boolean logic functions represent? Let's see. Now, Boolean logic functions are categorized into two things. Those are SOP and POS. Everyone knows what is SOP, that is sum of products, and the other one is product of sums. Product of sums. Now, this sum of products are also called as, are represented with min terms, which are represented using a small m, and it is also represented using summation. Whereas product of sums are represented using max terms, which is represented using capital M, and a pi is the symbol used for representing that particular thing. Now, a standard expression for my SOP is, for example, if I am having a function f of a comma b comma c, then this can be represented as, if it is represented like this, ab plus bc plus ca. Now this I call it as a standard SOP expression. Whereas by standard POS expression can be represented as f of a comma b comma c is equal to a plus b dot b plus c dot c plus a. So you got two different expressions. This is sum of products, this is product of sums. Now this standard expressions contains some product terms, it got some sum terms. Now this standard expression can be represented under canonical form. What do you mean by canonical form? I will write the expression so that you will understand the expression first. F of a comma b comma c is equal to a b dash c, a b c dash, a b c. Now this is called as canonical form, this is standard form. Now what it is making difference between standard SOP and canonical SOP is, now if you observe clearly, my standard form contains only two literals or two variables in my given product terms. For each product term it contains two variables, whereas my function contains three variables as my function, but each product term contains only two literals. Now if I observe the canonical form, each product term contains all the three literals. So that is the difference between standard SOP and canonical SOP form. Now if you see a b dash c, now that is 1 0 1. This is a b c dash 1 1 0, a b c 1 1 1. So I can represent this expression as summation m of 5 comma 6 comma 7. So this is my expression which is represented using midterms, that is canonical form. The same thing I cannot represent for my standard SOP. Similarly for my canonical POS form. So canonical POS can be represented as f of a comma b comma c is equal to a dash plus b plus c dash dot a plus b dash plus c dash dot a plus b plus c. Now this cannot be represented as pi capital M of, now this is dash means 1, normal variable is 0, 1 0 1, that is in max terms. Whereas for my SOP, normal variable is 1, dash is 0 here. Now here same, this is 0 1 1, this is 0 0 0. So my 0 comma 5 comma 6 is my POS max terms. So this is how you represent everything under SOP as well as POS. Let's see the M notations for a 3 variable. Let's see how those M notations are represented for my 3 variable thing. Now for example, if I am having 3 variables as A, B, C. So 3 variables means number of combinations that I can take is 8 combinations. So 3 variables I am considering A, B, C as 0 0 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6 and 7. Now my min terms. Min term can be written as this as small m naught, and this can be represented as a dash, b dash, c dash. This can be written as m1 as a dash, b dash, c. m2 can be written as a dash, b, c dash. m3 can be written as a dash, b, c. m4 can be written as a, b dash, c dash. m5 can be written as a, b dash, c. m6 can be written as a, b, c dash, and m7 can be written as a, b, c. This is min term representation, right? Now similarly, I want to represent for max term. Max term. This can be represented as m1, capital M1, and this will be a plus b plus c. This is m0, this is m1, which is a plus b plus c dash. m2, this can be written as a plus b dash plus c. m3, capital M3, that is a plus b dash plus c dash. Now m4 can be written as a dash plus b plus c. m5, which can be written as a dash plus b plus c dash. m6, which can be written as a dash plus b dash plus c. m7, which can be written as a dash plus b dash plus c dash. So this is what called as m notations, and these m notations are different for min terms and max terms, and these min terms are represented with 1 on K-map and 0 as on K-map. Now these two variations you need to observe while representing whether it is a min term or max term onto a K-map. So this is what you need to observe when representing a K-map on a K-map with a min term as well as a max term. Okay. Now, like for example, now we are given any K-map. If I am having K-map like this, now these terms are called as min term representations. Now what is min term representation? If this particular thing is represented with A, B, C, D, this particular thing is called as A dash, B dash, C dash, D dash. Now if I am having a K-map with zeros representation, then and I am having A and BC value. So this particular thing, that is 0, 0, 0, 1, 1, 1, 1, 0. So this thing can be represented. This is A dash and A. So this is A dash. Now this is B dash plus C. This is. So this becomes, this is A, this is A dash. So this becomes A plus B dash plus C as one term. Now this becomes A dash plus B dash plus C dash. So this is what makes difference between min term as well as max term onto K-map. Now when max terms are given, for example, now these max terms are given, I can convert these max terms to min terms. How? You just remove these three things and whatever not available, the not available things are to be represented using ones. So these parts if you place as ones, this becomes min term conversion. So I can convert the given max terms to min terms by just removing these zeros and placing remaining empty cells with ones, so that K-map will represent you a sum of product form of K-map. So this is what related to sum of products and product of sums. Here we are going to end our session. Thank you one and all.